Okay, so question number 7 is to write the Lewis structures of bromine, trifluoride, chlorine, pentafluoride, and iodine heptafluoride. Identify those in which the octet rule is not obeyed. Okay, so let's start off with the bromine tetrafluoride. And when we write out the Lewis structures, we want to first find out the total number of valence electrons in the structure. So in the case of bromine, there are 7 valence electrons. And for fluorine, there are also 7 valence electrons. And since we have 3 fluorine atoms, we multiply that by 3. And when we add this together, we get a total of 28 valence electrons. So now when we write out the Lewis structure, we'll have bromine as our central atom. And then I'm just going to draw single bonds to all of the fluorine atoms. And I can also show all of the lone pairs on the fluorine atoms as well. So now if we count out how many electrons I've drawn so far, each bond contains 2 bonding electrons, and we have 3 bonds, and then each fluorine contains 6 electrons in the form of lone pairs. So I only have 24 out of the 28 electrons drawn in this structure. So I'm just going to put the remaining 4 on my central bromine atom, since I'm not able to form double bonds. Okay, so this is our final Lewis structure, and we can see that it does not obey the octet rule. So let me just put at the top here that the bromine can have an expanded valence shell, and it typically occurs when we have electronegative terminal atoms, such as the fluorine. So let's move on to the next example, where we have chlorine pentafluoride. So if we were to calculate the total valence electrons, chlorine has 7, and fluorine also has 7, but there are 5. So when we add these values up, we get a total of 42 electrons. So now let's show chlorine as our central atom. And then I'll draw in 5 single bonds to fluorine. And I'll draw in the lone pairs. So if I count out how many electrons I've drawn so far, I only have 40 out of the 42. So I'm just going to put an extra 2 electrons on the central fluorine atom. So now you can see that for this example, the chlorine also does not follow the octet rule. For the same reason, it's able to expand its valence shell. And then for our third compound, we have iodine, heptafluoride. So let's calculate the total valence electrons. Iodine contains 7. And fluorine also contains 7. And we have 7 atoms. So adding these all up, we get a total of 56 valence electrons. So again, we're going to show iodine as our central atom, and then just draw out 7 single bonds to fluorine. So already we can see that the iodine also does not follow the octet rule. So now let's draw in all of the lone pairs. Okay, so now if I count out all the electrons in this structure, we'll see that we already have our 56, so we don't need to draw any more lone pairs on the iodine. So these are the 3 Lewis structures. So let's see what the junior tutor said. Is to step 1, list the elements, their valence electrons, and determine the total valence electrons. If the charge is present, add the value of the charge to the total valence electrons when it's negative, or subtract if it's positive. So for all our examples, they didn't contain any charges, so we didn't need to do that step. They got 28 for the first compound and had the same Lewis structure that does not follow the octet rule. For the second structure, they had 42 valence electrons and the extra lone pair on the chlorine. And for the last structure, we just have iodine with the 7 bonds to fluorine, and that follows our rule. Well, it already contains all the electrons that we need, and it also does not follow the octet rule. So this solution is correct.